Okay, so we're going to talk about special cases in 5.1, and then we'll look at some word problems. So this is 5.1. You can write what you feel you need to write. So you have to know it. Okay. So a system having at least one solution is called a consistent system. Okay. Here, the lines are independent of each other, and the system is called an independent system. That's this one right here. Okay. So most of the ones we do look like this. The lines intersect at one place. You have one solution. Okay. It's consistent. It's also called independent. And then it's also has a unique solution because there's just one answer. So these are our normal ones. So like what you just did on the warm-up, 5, 7, that's an independent system, a unique solution, and it's consistent. Okay. You will have to know this vocabulary. And these pictures will be given to you on a quiz, and you have to label it. Yep, all 3 terms. So this is the one solution. Same unique solution is saying one solution. Oh no, I want you to write these too. Oh, yes. Yes. What? So these are slopes. So the slopes are not the same, so that means they intersect. B would be y-intercept. Okay. So this says 1 point in common. If the lines have equal slopes and the same y-intercept, then they're the same line. They're called coincident lines. So in math, we say coincident. They are also, we say dependent. And they have at least 1 point, 1 solution, so they're also consistent. So these are consistent independent. These are consistent dependent. Okay. This would happen when you're solving if you get infinitely many solutions. Okay, that occurs if your x and y both cancel, and then you get a true statement. You would not have to write, so on a quiz, you would not have to write infinitely many solutions. It would be these 3 words that I would be looking for. You will be given like a word bank, and you will just label each one with the correct terms. Now, you could use the terms more than once, like consistent, you would use both places. Okay, if the lines are parallel, then they have the same slope, different y-intercepts. But since they have the same slope, they will never intersect. So they are called inconsistent. Inconsistent. And that is the only word you need for these, inconsistent. This happens when you're solving and your x and y's both cancel, and you get a false statement. Therefore, there is no solution. Again, the only word you would need to write would be inconsistent.
So the first one you can only have one.
One answer, yes. This is like our normal ones we've been solving. You get one solution, one x, one y. So most of the time, they are unique solutions. Okay, most of the time. These last two, the dependent and inconsistent, are the special cases. It's x and y's both cancel. So we'll look at a couple examples. Okay, we're going to solve using any method, and then we'll label them as consistent, inconsistent, or dependent. Okay, so I would use elimination since your x, y's equals everything's lined up. I'm going to have to multiply though. So what equation would I want to multiply? The top one, and what would I want to multiply by? 2. Because 2 times 3 is positive 6, and positive 6 and negative 6 would cancel. So that's 6x minus 10y equals 30. Okay. Now that I have opposites, I can add. So 6 and negative 6 cancel. But then I do 10 plus negative 10. Well, that also cancels. So if everything cancels, that means I have a 0. And then negative 30 and 30 is also 0. Is that true? Does 0 equal 0? Yes. So this has infinitely many solutions. Okay. So I want to label it as consistent, but then it's also dependent. Those lines would be coinciding lines, but that's not on our list that we have to use for these. Okay. All right, look at the next one. So you could, if you want to do substitution, you could do substitution. You just have to get a variable by itself. I'm still going to do elimination, and I'm going to multiply the bottom equation. So we have to think just a little bit. Okay. What I want to multiply this, and I want to be able to get a 3. So I have to think about what could I multiply by -1/3 to get -3. So you might have to try a few things in your calculator. You might, you could also divide 3 divided by 1/3 to know the number you need. You know it's not 3 because if you do 3 times 1/3, that's 1. So what did we figure out? What am I going to need to multiply by? 9. I'm going to have to multiply by 9 because that will give me -3. So that's -3x. And do 9 times 2/3. What do we get? 6y. And then 9 times 4. 36. Okay? Now that I have opposites, so opposites mean you can add. My x's cancel and my y's cancel, so leaving me with 0 on the left. And 9 plus 36 is 45. So is that true? No? That is false. So this has no solution. And then what word would I use? Inconsistent. You don't have to write no solution or infinitely many solutions, but I like to include them now just so you can relate those that you know that infinitely many solutions, that's the same thing as being dependent. No solution is the same thing as being inconsistent, but those are the same thing. Okay? Questions about that? So those are special cases. Most of the time, your both variables don't cancel. You're able to get one unique solution. Okay. So let's talk about some word problems. So a lot of the word problems that you will do will be of systems, will be your basic total number, total amount. You know, that's kind of how these things go. This one is kind of like that, but it's a little bit harder to set up. So the ones we're going to do in the notes are kind of the more difficult ones. Okay, so there's still some of those basic ones, like on Schoology, that you will do. All right. So first thing you should do is read the problem. And focus on what the question is asking. So whenever you do a word problem, you need to focus on what the question is asking, so then you know how to get started. Okay, we want to identify our variables. So I know I have to use a system because the question says, how much was invested at each rate? So this is where I can find my variables. I have each rate. So the word each tells me I'm looking for more than one thing, which means I need a system. So I'm going to need at least, I'm going to need 2 variables and 2 equations. Okay? So 2 variables, 2 equations. So I want to know how much was invested at each rate. So let's say x is amount invested at 10.5%, so that's 1, right? And then y is the amount invested at 12%. Okay, so I have my two variables. Now I need to get my two equations. So again, we're thinking about total number and total amount here. So it says a total of 12,000 is invested into municipal bonds. So that right there gives me one equation. How would I set that equation up? So just using the 12,000, I can set up one equation. So the total invested is 12,000. This is the amount invested at this rate. This is the amount invested at this rate. So x plus y equals 12,000. Everybody see that? How we got that equation? Okay. So the second one is a little bit trickier. So it says that the annual interest earned on two investments was $13.35. So this is simple interest. Okay, so I have to use that simple interest formula. I equals PRT. Okay. So let's look at the interest for the 10.5%. Okay, so that's I equals, P stands for amount you invest, so that's X, okay? At 10.5%, that's X. R is the rate, so 0.105. And T is the time. It says last year, the annual interest, so we're only looking at 1 year, okay? So that's 1. So the interest at 10.5%, if I multiply these together, is 0.105x. Okay? Now let's look at the 12% interest the same way. So this interest, my total amount that I invest, my P, is Y. That's what I invested at this rate. My rate is 0.12 and my time is also 1. So this is 0.12y. Okay. The total interest was $13.35. So this interest plus this interest is $13.35. Okay, so 0.105x plus 0.12y is 13.35. Okay, if you think about this as like a total number, total amount, the total number is this. This is talking about the interest, so I would have to put their interest rates with those variables. The 0.105 would have to go with x, the 0.12 would have to go with y, if this is this was talking about interest. Okay? But this is why we get that 0.105x, 0.125. Okay? Alright, so here's my system then. You can choose to solve this either way. I'm going to do elimination, but substitution is pretty well. You would like to do that. You might want to just get y or x by itself and plug that in. So if you like to do it that way, that's fine. If I do elimination, I'm going to multiply, what do I want to multiply the top equation by? Yeah, so if I'm going to do negative 0.105. Yeah, so then I could cancel my x's. Okay, and then I can add down. So if I add those, I got 0.015y, and then I got 75. And then for y, I got 5,000. Is that what you guys got? I need to find x. What's the easiest equation to plug this back into? Yeah, the top one. I know the total is 12,000. So if y is 5,000, then that means x has to be 7,000. Yes. Make sure your answers make sense. If you get a negative, you did something wrong. If you get a number that's bigger than 12,000, you did something wrong. The total is 12,000, so one of the variables couldn't be 12,000. Okay, and then let's answer the question. So 7,000 invested at 10.5%, and then 5,000 invested at 12%. Okay, questions about that? I'm not going to do the one that's in the notes because that will take too long. So let me make up a different one and let's set this up. So, going to be a very basic example, but it'll give you the gist. Okay. So let's try to get this set up. You don't have to solve, we just want to set up. So you first need to identify your variables. So what should x and y represent? Okay, the total amount of each one, not the cost. So amount. Okay, good. What's the first equation I can write? X plus y equals 200. And then the second equation, 2x plus 3y equals 450. Yep, good. So each type, that tells you two variables. So if you have two variables, you need two equations. Questions like this come up on the ACT, and a lot of times you don't know that you need a system. The word each, if you're looking for more than one thing, you're going to need more than one equation.